Hi everyone, hope you're doing fine. Welcome to another video from my channel. Last video we discussed about how we can use the chain rule for differentiating functions in the form of y equals f of g of x or y is equals to f of x whole to the power n. The link to the previous video will be given in the description below and I would really suggest you to check it out. Just as a sum up of the chain rule, the chain rule should only be used when we have a function in the form of y equals f of g of x, basically meaning a function inside a function, or y is equals function of x whole to the power n, and the formula for the chain rule will be dy by dx, the gradient function, is equals to dy by du multiplied by du by dx. However, today we will be learning about the product rule, where the product rule should only be used when we have a function in the form of y is equals f of x multiplied by g of x, or y is equals to u multiplied by v, where u and v are both functions of x. And the formula goes dy by dx is equals to u multiplied by dv by dx plus v multiplied by du by dx. So let me demonstrate by using the same example we used in the chain rule before. Now I can write this being the product of two functions of x, for example 2x squared plus 1 multiplied by 2x squared plus 1. Let's assume that this is u and the other function being v. So applying the formula we get dy by dx is equals to u, which is 2x squared plus 1 multiplied by the derivative of the function v, which is also 2x squared plus 1 here. So we write that being d dx of 2x squared plus 1, and then plus v, which is also 2x squared plus 1 as given here, multiplied by the derivative of 2x squared plus 1. Now simplifying we get 2x squared plus 1 multiplied by the derivative of 2x squared plus 1, which is basically 4x, as shown in my first video. When you differentiate a function in the form of ax to the power n, the derivative will only be an x to the power n minus 1. So for the case of 2x squared plus 1, 2x squared becomes 4x because 2 minus 1 is 1, and 2 multiplied by 2 becomes 4, and since 1 is a constant, the derivative of any constant will be 0. And for the next part, since this is basically the same thing, we can also write this being 2x squared plus 1 multiplied by 4x. Now if you notice, there are two of this 2x squared plus 1 multiplied by 4x terms, so we can say that we have 2 multiplied by 4x multiplied by 2x squared plus 1, because basically adding two things that are identical to each other is basically multiplying them with 2. So we finally get 8x multiplied by 2x squared plus 1. Now if you check with the previous method, the chain rule that we used before, you may notice that the answers are exactly same, 8x multiplied by 2x squared plus 1, and here we also get 8x multiplied by 2x squared plus 1, hence proving that the product rule is valid. Now let's move on to some practice questions. For number A, we have d dx of x squared multiplied with x plus 1 multiplied with x minus 2 whole to the power 7. So at first glance you might say, okay, there are three terms in this question which are x squared, x plus 1 and x minus 2 whole to the power 7. So how am I supposed to use the product rule? Because the product rule essentially consists of only two functions multiplied with each other. So for these kinds of maths, you have to ensure that your function is in the form of y is equals to u multiplied by v, where dy by dx will be equals to u multiplied by dv by dx plus v multiplied by the derivative of u, or du by dx. So upon further inspection, you might say that okay, I can multiply x squared with x plus 1 and get two different functions in the form of u multiplied by v. So let's do that first before actually differentiating the whole thing. So multiplying x squared with x plus 1, we get x cubed, as x squared multiplied by x is x cubed, and multiplying x squared with 1 is basically x squared, and then multiplied by x minus 2 whole to the power 7. So now we have the format of u, v, so marking them as v here and marking the first function as u. We can use the formula dy by dx is equals to u dv by dx plus v multiplied by du by dx. So differentiating this, we will get x cubed plus x squared multiplied by dv by dx as given in the formula, which is d dx of x minus 2 whole to the power 7, and then plus v du by dx, which is v here x minus 2 whole to the power 7 multiplied by the derivative of x cubed plus x squared, or u. So simplifying, we get x cubed plus x squared multiplied by the derivative of x minus 2 whole to the power 7. So if you notice, x minus 2 whole to the power 7 is exactly in the form of y is equals to function of x whole to the power n. So that means we have to use the chain rule for differentiating this function. So the previous knowledge of chain rule is also required. So applying the chain rule, we get 7 x minus 2 whole to the power 7 minus 1, which is 6, and then multiplied with the derivative of x minus 2, x minus 2 whole to the power 7 multiplied by the derivative of u, which is x cubed plus x squared in this case. So we get 3x squared plus 2x. So finally we get x cubed plus x squared multiplied with 7 into x minus 2 whole to the power 6, and since the derivative of x minus 2 is 1, so we don't have to write anything here, and then x minus 2 whole to the power 7 multiplied by 3x squared plus 2x. Now one last thing you could do is basically take a common factor of x minus 2 whole to the power 6 and then simplify it. So now let's move on to number b. So we have to find the ddx of this function, which is cubic root of x plus 5 multiplied with the square root of x minus 3. Now using the same formula for product rule, we have this as u and this as v. Since dy by dx is equals to u dv by dx plus u plus v du by dx, we can write this being u, which is cubic root of x plus 5, then multiplied with the derivative of v, which is root over x minus 3, and then plus v multiplied with the derivative of u, So we get cubic root of x plus 5 here. So simplifying, we get cubic root of x plus 5 multiplied with the square root of x minus 3. Now if you notice, this can't be directly differentiated as we need to use the chain rule for this. So rewriting that as x minus 3 whole to the power half, as according to indices rules, a square root is basically a half, plus root over x minus 3 multiplied with the derivative of cubic root of x plus 5, and we do the same for this guy as well, writing the power as 1/3 according to indices rules. So we get cubic root of x plus 5 multiplied by the derivative of x minus 3 whole to the power half, which is basically half x minus 3 whole to the power minus half, because n minus 1, which is half minus 1, is minus half, and then multiplied by the derivative of x minus 3, which is basically 1. So for this case I'm not going to write that down. So we get plus root over x minus 3, and then using the same rule, and using the same chain rule, we get 1/3 of x plus 5 whole to the power minus 2/3 whole to the power minus 2/3, and then multiplied with the derivative of x plus 1, which is also 1. So for our final answer, you can either write the whole thing being in index form, or you can simply write them in their exact form, which will be, for this case, cubic root of x plus 5 divided by 2 root over x minus 3. This is because if you have anything to the power of minus 1 by n, then its exact form will be 1 by nth root of a, or a to the power 1 by n. So finishing the answer, plus doing the same for this term, we get root of x minus 3 divided by 3 multiplied by the cubic root of x plus 5 whole square, applying the same indices rule as shown before. For number C, we have to find out ddx of a square plus x whole to the power 1/3, writing it in its index form, multiplied with 2ax plus 3b. So applying the product rule, we get u, which is a square plus x whole to the power 1/3, multiplied by the derivative of 2ax plus 3b, and then plus v, which is 2ax plus 3b, multiplied with the derivative of a square plus x whole to the power 1/3. So simplifying, we get a squared plus x whole to the power 1/3 multiplied with the derivative of 2ax plus 3b, which is basically 2a because 3b is constant. This is mainly because you are differentiating the expression with respect to x, as denoted by the dx below, so everything except for x will be regarded as constant. So we get multiplied with 2a plus this thing, which is 2ax plus 3b multiplied by the derivative of this guy, Now using the chain rule, we get 1 by 3 or 1/3 multiplied by a square plus x whole to the power minus 2/3, and then multiplying again with the derivative of a squared plus x, which is basically 1, as a square is a constant, so the derivative of a squared is 0, and the derivative of x is basically 1, so we don't have to write it. And finally we get 2a cubic root of a square plus x plus 2ax plus 3b divided by 3 multiplied with the cubic root of a squared plus x, which itself has a whole square.
So for number 2, we have to find out the value of dy by dx at x equals to minus 1. Therefore,
In this case we have d dx of 2x plus 3 multiplied with x plus 2 whole to the power 8. We get 2x plus 3 multiplied with the derivative of x plus 2 whole to the power 8. So x plus 2 whole to the power 8 plus v, which is x plus 2 whole to the power 8 multiplied with the derivative of 2x plus 3, which was considered as u. So you get 2x plus 3 multiplied with the derivative of x plus 2 whole to the power 8. So using the chain rule, you get 8 multiplied by x plus 2 whole to the power 7, and then multiplying it, the derivative of x plus 2, which is basically 1, so I'm not writing that, just like the previous examples, plus x plus 2 whole to the power 8 multiplied with the derivative of 2x plus 3, which is basically 2. And now we finally get 8 multiplied by 2x plus 3 multiplied with x plus 2 whole to the power 7 plus 2 multiplied with x plus 2 whole to the power 8. Now we are not finished with the math. The only thing we have remaining is to find out the value of dy by dx at x is equals to minus 1. So we simply need to substitute x equals to minus 1 here. So we write when x is equals to minus 1, dy by dx for the gradient function, if you remember, will be basically 2 multiplied with minus 1 plus 3, then multiplied with minus 1 plus 2 whole to the power 7 plus 2 multiplied with minus 1 plus 2 whole to the power 8. So 8 multiplied with 1 multiplied with 1 is still 8, and 2 multiplied with 1 is also 2. So 8 plus 2 is basically 10. So that's the answer. So for number 3, the last method, so we have d dx of x to the power 5 multiplied with 10x plus 6 whole to the power half, writing it in its index form so that the product rule application can be easier. So assuming this is u and this is v, so we get, according to the formula, x to the power 5 multiplied with the derivative of 10x plus 6 whole to the power half plus 10x plus 6 whole to the power half multiplied with the derivative of x to the power 5. So simplifying, we get x to the power 5 multiplied with the derivative of 10x plus 6 whole to the power half, and using the chain rule we get half 10x plus 6 whole to the power minus half according to the chain rule, and then multiplying with the derivative of this guy, which is 10x plus 6, and the derivative will be 10, so I'm directly writing it down like this, plus 10x plus 6 whole to the power half multiplied with the power 5, which is 5x to the power 4. So finally, simplifying all of this, we get 2 multiplied by 10 is 5, so 5x to the power 5, and then multiplying with 10x plus 6 whole to the power minus half plus 5x to the power 4 multiplied with 10x plus 6 whole to the power half. Now the only thing left is substituting x into our expression of dy by dx, and we will be done. So when x is equals to 1, we get 5 into 1 to the power 5, which is also 1. 10 into 1 plus 6 is 16, so 16 to the power minus half plus 5 multiplied with 1 to the power 4, which is also 1, and then as same, 10 into 1 plus 6 is 16, so 16 whole to the power half. So 16 whole to the power minus half, 1 by root over 16, or 16 to the power half, so which is 1 by 4, and 16 to the power half is basically 4 according to indices rules. So we have 5 by 4 plus 5 into 4, and adding both we get a fraction of 85 by 4. And now let's move on to the last rule that we have, which is quotient rule. Now as the name suggests, you only have to use this when you have two functions that are in the form of y is equals to function of x divided by g of x, or u by v. In the previous one we had u multiplied by v, and in this case we have u divided by v, so it's very important to see the distinctions between them. So the formula is dy by dx is equals to v multiplied with du by dx, which is a derivative of u, minus u multiplied with dv by dx, and whole divided by v square. So let's start with an example. We have y is equals to 5x squared divided by 3x plus 1. So assuming this is u and this as v, and according to this formula we can use the quotient rule, and so we have dy by dx equals to, we have v, which is 3x plus 1, multiplied with the derivative of u, which is 5x squared in this case, subtracted with u, which is 5x squared, multiplied with the derivative of v, which is 3x plus 1, and then dividing the whole thing with v squared, which is 3x plus 1 whole square. So going through this step by step, we have 3x plus 1 multiplied with the derivative of 5x squared, which is 10x, subtracted with 5x squared, multiplied with the derivative of 3x plus 1, which is 3, as according to the formula. The derivative of ax to the power n will be equals to a n x to the power n minus 1, which was discussed broadly in our first video. So the remaining part is dividing the whole expression by 3x plus 1 whole square, which is the v, and finally we get 30x squared, which is 10x multiplied with 3x, and then we multiply with 1 plus 10x, as 10x multiplied with 1 is 10x, and subtracted with 15x squared, as 5 into 3 is 15, and divided by 3x plus 1 whole square, and finally simplifying we get 15x squared, as we have 30x squared and 15x squared. So 30 minus 15 is 15 plus 10x, and divided by 3x plus 1 whole square. Now let's move on to the main questions. So for number A, we have ddx of x plus 3 divided by 2x plus 1. And if you remember the formula for the quotient rule, dy by dx is equals to v multiplied by du by dx minus u multiplied by dv by dx and whole divided by v squared. So this will be our u and this will be our v. So applying the formula, we get v squared at the bottom, and at the top we have 2x plus 1 multiplied with the derivative of x plus 3 subtracted with x plus 3, which is u, as accordance with the formula, and then multiplied with the derivative of 2x plus 1, which is v. So simplifying we get 2x plus 1 multiplied with the derivative of x plus 3, which is 1. As mentioned earlier, the derivative of x is 1, and the derivative of any constant like 3 is 0. So we get 1 here, and subtract it with x plus 3, and then multiply with the derivative of 2x plus 1, which is 2, and then divided by 2x plus 1 whole square. So further simplifying, at the top we have 2x plus 1 subtracted with 2x and 6, so divided by 2x plus 1 whole square. So as you can see, the 2x terms cancel each other out, and the remaining part is minus 5, as 1 minus 6 is minus 5. So the final answer is minus 5 divided by 2x plus 1 whole square. So for number B, we have the derivative of 3x squared divided by 2x minus 1 whole square. So assuming this is v and this being u, and since our formula is given as this, so using the formula we have the whole thing divided by v squared. So since 2x minus 1 whole square is the v, so the v square will be 2x minus 1 whole square with another whole square. So make sure you don't do that mistake. At the top you have v multiplied by the derivative of u, which is 3x squared here, subtracted by u, which is 3x squared, multiplied with the derivative of v, which is 2x minus 1 whole square. So further simplifying, we get 2x minus 1 whole square multiplied with 6x, because 3 into 2 is 6, and x to the power 2 becomes x to the power 1 because 2 minus 1, as discussed previously, subtracted with 3x squared, and then multiplied with the derivative of 2x minus 1 whole square. So using chain rule, just like before, you have 2 there and 2x minus 1 whole to the power 1 because 2 minus 1, and then multiplied with the derivative of 2x minus 1, which is 2, and divided by 2x minus 1 whole to the power 4, because according to indices rule, if you have a to the power n whole to the power m, then you have a to the power n multiplied with m, and finally we get 6x 2x minus 1 whole square subtracted with 3 into 2 is 6 and 6 into 2 is 12, so 12x square multiplied with 2x minus 1, the whole divided by 2x minus 1 whole to the power 4. Now if you notice, there is at least one 2x minus 1 above and below the fraction. So we can take a common factor of 2x minus 1 to get rid of at least one of them by dividing. So we get 6x multiplied with 2x minus 1 subtracted with 12x squared, and then whole divide with 2x minus 1 whole to the power 4. So finally this becomes cubed, as one of them is cancelled out, and 4 minus 1 is 3, the power is 3, and at the numerator we have 6x multiplied with 2x minus 1 subtracted with minus 12x squared. So you can choose of, so further simplifying we get 12x squared here, so 6x so further simplifying, 6x multiplied with 2x gives us 12x squared, and 6x multiplied with minus 1 gives us minus 6. So in the end we have minus 6x divided by 2x minus 1 whole to the power 3, or cubed. This is because 12x squared minus 12x squared is simply 0. For number D, assuming this is u and this is v, dy by dx would simply be root of x plus 1 whole square, and at the top we have v, which is root over x plus 1, multiplied with the derivative of the cubic root of x, which can be written in its index form being x to the power 1/3, subtracted by x to the power 1/3, and multiplied with the derivative of the v, which is root of x plus 1, which can also be written as x plus 1 whole to the power half. So, just like before, at the bottom we have x plus 1, and at the top we have x plus 1 whole to the power half, or root of x plus 1, multiplied with the 1/3 of x to the power minus 2/3, subtracted with x to the power 1/3, and multiplied with the derivative of x plus 1 to the power half, which is by using chain rule to get x plus 1 whole to the power minus half. So here, just like the previous math, we will multiply both sides, the numerator and denominator, with x plus 1 to the power half, so that this term becomes 1 and this term having the power of 3/3. So simplifying, at the bottom we have x plus 1 to the power 3 by 2, and the first term becomes 1/3 of x plus 1 multiplied with x to the power minus 2 by 3, subtracted with half of x to the power 1/3 into 1, because as explained before, a to the power n multiplied with a to the power minus n will always be 1. So for the last math, number E, assume that this is u and this is v. We have dy by dx being equals to a x square subtracted with bx subtracted with c whole square, and note that a, b, and c are constants only because we are differentiating with respect to x, as denoted by the bottom variable of the differential operator. So at the top we have v, which will be a x square minus bx minus c, multiplied with the derivative of the function u, which was considered being ax square plus bx plus c, subtracted by the same function u as considered before, and you have the derivative of v, so further simplifying, we get at the top as being ax square minus bx minus c, and the derivative of ax square plus bx plus c will be 2ax plus b, and subtracted with ax square plus bx plus c multiplied with 2ax minus b and whole divided by ax square minus bx minus c whole square. So multiplying we have 2a squared x cubed, and then with this we have minus 2abx square, and with c we have minus 2acx. Repeating the same procedure for b, we have abx square subtracted with b square x minus bc, and then on the right side we have minus 2a squared x cubed, and then so 2ax multiplied with bx will be minus 2abx square because of the minus sign, and then 2a with c will be minus 2acx, and for minus b we have plus abx squared, then b square x plus bc. So if you notice 2a squared x cubed will be cancelled out by minus 2a squared x cubed. Then you have minus b squared x cancel out with plus b squared x, minus bc with plus bc. So the only terms remaining are highlighted so that it's easy to understand. And as usual, whole divided by ax square minus bx minus c whole square. And if you also notice, you have minus 2abx square plus abx square, and then minus 2abx square plus abx square, meaning minus 2 plus 1 minus 2 plus 1, which is basically 2, which means there are minus 2abx squares. So we get minus 2ax multiplied by bx plus 2c divided by ax squared minus bx minus c whole square. So to sum up for all three techniques, first we have chain rule that can be used for only functions